Hello guys, hope you are doing well. Welcome to Engineering Hotspot. Today I am going to discuss some problems that came in set 2 as well as set 1 in GATE 2020 from subject Engineering Mechanics. So let us begin. First we will look for set number 1 of GATE 2020. So in that set, question number 5 is from Engineering Mechanics, and you can see the question. They have given this system. This is basically a truss. Okay, so they have said the member carrying zero force member in the truss shown in the figure for any load P greater than 0 with no appreciable deformation of the truss. That is, there is no appreciable change in the angle between the members. Means we are not disturbing anything. We are not changing the value of force, any force. So in that case, you need to find the various members that are zero force or that are carrying zero force. So there are two things that you should remember while solving the problems of truss or while observing whether the member is a zero force member or not. So first point is that a joint with two members, a joint with two members. So let me take this as the joint. Suppose I have taken two members. Suppose this point is A, this point is this force. This force is suppose FAB. This force is suppose FAC. Then what does this concept says? It says if a joint is free from any support or any external load like if force is applied from outside or if there is support, maybe roller support or hinge support. If a joint is carrying two members such that the joint is free from any support or any external force, in that case the force in both the members will be zero. Means FAB equals to 0 and also FAC equals to 0. So this is the first concept for zero force member. Now coming to second concept. Second concept says if a joint is formed by three members, joint formed by three members such that two members are collinear. You can see which two members are collinear. Member ABA or AB and BC. Okay, these two members are collinear. Collinear means what? Lies in a same line. So if two members are collinear and the third member is not collinear with the other two, in that case the force in non-collinear member will be zero. But the condition is that the joint should carry only three members and the joint should be free from any external load or support reaction. So in this case, in this diagram, for this diagram, FBP means force in this member is 0. Okay, so whenever you see that it's a 0 force member, you can eliminate that member from the truss system. Okay, so these are the direct way by which you can observe whether it is a 0 force member or not. But there may be some additional 0 force member which you need to observe by looking at the truss system. Okay, so basically those 0 force member may be present at the support, basically at the support. So we will observe this truss system, then you will get to know. So if you apply this second concept, this second one, you can very easily see that this joint B is having three members. The joint B is having three members, AB, BC and BF. So three members are there and this joint is free from any support or any external load. So in this case, and as well as member AB and BC are collinear in same line. So FBF is 0. Similarly, if you observe this joint Z, then there are three members FG, GH and GC. So this GF and GH member are collinear line in same line, but this GC member is non-collinear and this joint is free from any support or external load. So FGC is also 0. Similarly, if you observe this joint D, three members are there, CD, DE and DH. So again, if you apply the second concept, then FDH will be 0. So we have determined three members. Now see if we can determine the other members as well. If you look at this joint, then you will see two members, but it is having a support. A support reaction will be observed, so you cannot apply step 1 or concept 1. Similarly, you cannot apply the concept 1 at E also, and nowhere else you can apply these two concepts. So we are left with only these three, but you will be in a very hurry to mark option maybe B, but if you mark that option you will get 0 marks, because I told you that in a truss system it is not necessary that only these two steps can give you a 0 force member. There can be more 0 force member that are hidden, that we need to observe with the help of this by looking at this system. So basically those those hidden members are basically near the support. Okay, so if you observe this this support carefully, what you can see, this dimension is 1, this is also 1. So what will be this angle? Just tell me. This angle HED, this will be 45 degree. If you extend this line in this way, if you extend this line in this way, you can see this angle is 45, so this angle will also be 45, vertically opposite angle. In maths, hope you have done those things. So you can see this 45 and this 45 makes 90 degree. It shows that if you apply method of joint, at E, what is method of joint? Just remove that joint along with this member, connected members. Okay, so here I am doing that. So this is member FED, this is member FEH, and this is the support. Basically, what kind of support is that? Roller support. So in roller support, you know that only one reaction is there, that is perpendicular reaction or vertical reaction. So since this support is inclined in 45 degree, so this vertical reaction will be like this way. This is E. So this will be vertical reaction will be RE. Why there will be no horizontal reaction? Because there is roller. So along this line, support is free to move. So we will not observe any reaction. Reaction is observed when we are trying to obstruct anything. Okay, we are not trying to obstruct this motion, this motion, but we are trying to obstruct this vertical. This, if you observe it carefully, this is 45 degree, and this is also 45 degree. So if you observe the carefully, this RE will be in same line with FEH. RE will be in same line with FEH. So what does it mean? It means that RE is equals to FEH. Okay. Now if RE is FEH, then this force is left out. Then what will you do with this force? There is no other force to balance this force. So this force needs to be zero. So in this case, FED should be 0. Just you need to draw this, and just it's a case of geometry. No need to do anything extraordinary. Just draw the geometry, take net force along the line equals to 0, net force perpendicular to the line equals to 0. You will get it. You will see that FEH is same as RE, but there is no force to balance FED, so FED will be 0. Now apply method of joint at point D. If you apply method of joint at point D, you will have three forces, FDE, FDC, and FDH. Is there any other force? No. This is perpendicular. You can see these two forces, FDC and FDE, are collinear. So if you apply net force along horizontal direction equals to 0, so you will get to know that FDE will be same as FDC. And what you have got, FDE, FED is same as FDE, not a problem. You can change this way. Okay, these both are same. So since FDE is 0, so FDC is equals to this, so this is also 0. But this is perpendicular, and we have observed previously that FDH is 0, so no need to do anything else. So these are the members we have determined. Now look at support A. If you can do the similar thing what we have done here, if you cut this out, you will get this force and this force, as well as this is a hinged support. In hinged support, you know, two reactions will be observed, vertical and horizontal. So there is horizontal reaction, that is HA, and there is vertical reaction VA. Okay, so if you take method of joint at A, you will take this force as well and this force, and if you try to do that, means net force in horizontal direction equals to 0, net force in vertical direction is 0, you will get to know that this force and this force will not be zero, because there is something to balance this force and this force. So their values will not be zero. And for the rest of the part, you directly observe from this first concept and second concept. But the hidden members which are zero, that is observed near to support. So we are observing at the support for the hidden members. So that in this way we have determined the zero force member. So we have observed that BF member is zero, DH member is zero, GC is zero, CD is zero. Yes, and DE is also zero. See, these five members are zero force member. Is there anything else? No. Option A, B, D are wrong. Only option C is correct. So this is the answer for this question. If you still feel any doubt, we will discuss when we will study trust system. Okay. So let us move to another question. So question number 29, what does it say? Question number 29, they have given one diagram. They are saying that there is a 2 kg block, uh, and it is resting on a smooth horizontal surface. They have mentioned smooth. Okay, so friction is not observed. It is placed on a horizontal surface, means if it is a plane, this there is a thread, and not thread, basically something elastic object they have said. No, yes, massless elastic cord they have said, attached to a massless elastic cord. This cord is elastic, means if you elongate it, it will get elongated, and when you remove it, it will again come back to original position. What we have studied in SOM, strength of material, those concepts will be there. So in elastic member, you can think this as a spring only. So suppose there is a spring that is attached, and to that is hinged at this point, and on this surface this spring is there, and mass is placed here to the end of this spring. So you are applying, the velocity is applied to this, so it will move in this way. So that's what we are saying, that the cord is hinged at O and is initially unstressed, means at this position the spring is not stretched. Okay, is not stretched means it is at a natural length or natural position, and the spring remains elastic, always elastic, means it is within the elastic limit. So in that case, you know that within an elastic limit or within the proportional limit, Hooke's law is obeyed. The block is given a velocity of v 1.5 meter per second. So at this point, the velocity 1.5 meter per second is given perpendicular to the cord. Okay, in this way you can see. And they have said the magnitude of velocity in meter per second of the block at the instant the cord is stretched by zero point 0.4 meter. So now we have stretched the cord, or the during the motion the cord gets stretched by zero point 0.4 meter. Stretched means, suppose at this, after moving at this point, it get elongated by 0.4 meter. Previously it was 0.5 meter, now it become 0.9 meter. This what they want to say, elongate by 4 meter. So what they are saying the magnitude of velocity at this instant. What will be the magnitude of velocity? So you know that velocity is always perpendicular to the motion of this object, or it's tangential. The motion is the velocity is tangential in tangential direction. So okay, what you say, just take this point as A, this point as B. Now we will apply conservation of energy principle. Why? Because they have said the surface is smooth and no other external irreversibilities are observed. So in that case we can conserve the energy. Remember, energy conservation can be applied whenever friction or drag is absent. Okay, so it will be very easy to use this. So we will take the total energy at A, and that will be same as total energy at B. So what will be the total energy at A? You can see what are the things that are observed at A. You have given the velocity of 1.5 meter per second at the position A. So there will be kinetic energy. So this will be half, we know kinetic energy is half m v. I am taking this velocity as va square. Okay, and is there any other energy? You need to consider the potential energy here because the um, block is lying on a horizontal surface. It is not at any height, so gravity effect will not be there. Whenever the gravity effect comes in picture, then you will take potential energy. Okay, so this will be equals to, suppose at this point B, this there will be some velocity that will be half m v square. Okay, plus remember one more thing, since it's a elastic member, its elongation is observed, so you need to consider that energy as well. So that energy is basically called elastic potential energy or spring potential energy, elastic potential energy, and that is equals to half kx square. You know, you have studied in physics and other subjects as well. So that will be half k. K is the stiffness of this elastic cord. Okay, and x is basically the deformation or the elongation that is observed for that elastic cord from the natural position. So just substitute the value. You can cancel this 1 by 2 on both sides. So basically the mass they have given, this block mass is 2. Just substitute 2 into velocity they have given 1.5. This will be equals to mass. Mass is 2. We don't know the velocity at this point. We require to know that. So since we are required to determine that value, we will take it as VB only. Plus, as they have given the value of stiffness, means K, that is 5. So I will write K is equals to 5 Newton per meter. And what is X? X is basically the elongation or deformation they have given. They said that the cord is stretched by 0.4 meter from the mean position or the natural position. So this will be 0.4 square. So if you calculate the value, you can calculate the value with the help of get calculator that I recommended last class. So if you calculate this, you will get something near around 1.36 meter per second. So this will be the velocity at position B when the spring has stretched by 0.4 meter. So option C, you will see this is correct. So if you still have any doubt, please mention in the comment box. So let us see the another question that came in set 2. Basically it came in set 2. This is question number 5, and this is basically they wanted to know the free body diagram. So they wanted to know if you can draw the free body diagram of this figure. So, but they wanted to know the free body diagram when the roller is just about to climb over the step. So, roller is just about to climb over the step means when the roller is at this position, it is in if it is in contact with this ground, this horizontal, this surface at this point. as well as this point. Okay, but when it start stepping up, in that case it will lose contact. You can think, just it's a case of imagination. If this ball is, if this ball is at some strikes at this point, it will move in this way now. So it will lose contact at this point, it will lose contact at this point. So since it will lose contact at this point, you will not have any contact reaction. Contact reaction means normal reaction basically. So basically we need to draw the FBD when this ball, this ball, or what they have said something in around a spherical object or something like that. So when this, for this position, okay, and they have said one more thing, that there is a coefficient of static friction between the roller and the ground, including the edge of the step. Means at this point also, everywhere friction is observed. This surface, as well as this surface, this corner, everywhere. So you need to consider that as well. So whenever you try to draw FBD, you need to remove all the contact surface and include all the forces that are present. So okay, I will remove all the surface, and now I will try to draw this at this point. This is the center of this object. The weight of the roller they are given as W. You know that weight always acts downward direction. So this is weight that acts from the center. This is W. And since it has lost contact with this surface, this horizontal surface, so you will not observe any vertical reaction or normal reaction. Okay, so no need to consider that. Now they have said that there is external force that is observed. You need to include that. This is external force F. Now they have said, now you can see at this point this object is in contact, this edge, at this edge. Okay, so you need to consider that reaction, this block or this roller applies force on this step in this way, in this way. So this step will apply force on this roller in this way. You know, by third law of Newton, every action has equal and opposite reaction. So action is applied, so reaction is observed. So at this point, at this point, you will see a reaction. I'm taking this reaction as R. Okay. See, this this roller is trying to roll. Okay, it's trying to roll while moving up. So when it's trying to roll, there is some force as well. So we know that friction always opposes the relative motion. Okay, friction acts opposite to the relative motion. So you can see this block is trying to move in this way. This motion is in this way. Friction force will be observed in this way. And you know that friction is always the maximum value of static friction, that is equals to mu s into reaction that is observed at this surface. So that is R. So any other forces we need to consider? Let's see. No, just these are the forces we will consider in our FBD. So if you look option number D, option number D, yeah, option number D is matching with our answer. So option number D will be the correct answer for this question. If you see option number C can be the possible choice if roller is in contact with this surface, is still in contact with this surface, it has not stepped up, it has not trying to step up or trying to climb up, it is at this point and it is striking at this point, and it is landing on this, it is on this surface. So in that case option C will be your possible choice. Okay, so hope you have understood how to draw the FBD. In FBD you will consider all the forces that are observed, all the external forces plus weight of the body plus normal reaction if it is there plus friction. So these all things you need to consider in your FBD. FBD means free body diagram. So if you still have any doubt, please mention in the comment box. So let us move to the last question that it is there. It came in set 2. Question number is 6. So this is basically they have given a disc they have given, and it is having a radius of r. At the top um, there is a slab, and it is moving this side with a velocity of v, and this lower slab is moving in right direction with a velocity of 2v. So they wanted to know what is the angular velocity of the disk due to this system or due to this arrangement. So how will you do that? There is a very simple step to solve this type of problem, that is called eye-center method. So what you will do, just take this sphere. You know that the velocity is in this direction, so the eye center will definitely be in this way, perpendicular to velocity. So it will be in along this line, and here also you can see the velocity is in this direction. So eye center of this will also be along this line, but we are not knowing where it is lying. So what we will do, we will take this as 2v, that at this point the disk is undergoing pure rolling or rolling without slipping. So in that case the velocity of this slab will be same as the velocity of this point, so that there will be no relative motion or no relative velocity observed at this point, and it will appear to have no slip condition. No slip condition you have, I think you have studied in fluid mechanics during boundary layer and all. So since this slab is having 2v, this point is also having 2v velocity. So I have placed 2v velocity of this point at this direction. And since this slab is having velocity of v in this way, this point will have a velocity of v in this direction. So now we know that along this line the eye center will lie, but where it will lie we don't know. So I will consider, suppose I will consider this point as the eye center. This is our center. Eye center means basically the point where the object will undergo only rotational motion. There will be no translational motion. So you will observe only rotational motion. So okay, that is called eye center. So this is point I, that is called eye center. This is the actual center of the disk having a radius of r. Now what you do, you just need to do velocity of point P divided by distance distance from eye center of this point, and this will be same as velocity of point q divided by distance of this point from eye center, that will be h2, and this will be what, same as omega. It's a pure rotation, so that's why we can use this concept v is equals to omega into distance. Okay, so you can see the velocity at point p is v, and what will be x1, since we don't know that distance eye center or where it is locating, you can take this distance from this q as x. Okay, so if this is x, if I to q is x, then I to p will be what, 2r minus x, because the total diameter is 2r. So just take 2r minus x, and this will be equals to 2v divided by x2. x2 is what, I to q distance, that is x. Okay, just now try to find the value of x. After solving, you will get x as, substitute this x value anywhere, here or here. So same, omega will be 2v by x. X is 4r by 3. So this will be, if you solve this, you will get 3v by 2r. So here we have determined the value of omega, and they wanted to know this value only. Option number D is correct. Here I have used capital R. This capital R is basically the radius only. Option D is correct. If you still have any doubt, please mention in the comment box. So now we have covered all the questions from set 1 and set 2 that came in GATE 2020. Thank you guys and have a nice day.